Good afternoon. My name is Okan Bulut. I'm from University of Alberta, Canada. And today my presentation is with my colleague from the same university, Damien Cormier. So I will be talking about a large-scale progress monitoring application with computerized adaptive testing. So both standardized tests and classroom assessments are used for monitoring student progress in a formative manner. So typically whenever we think of CAT, we think of standardized assessments to make decisions, to make pass-fail decisions, or to classify people, or more like a standardized testing occasions. But in our case, we are mostly talking about formative assessments being used in classrooms or schools for monitoring students, so that students who have learning difficulties can be diagnosed. And also we can evaluate the effectiveness of instruction. We can plan some additional activities for those struggling students, or we can even develop some instructional interventions depending on the amount of students who struggle with the content or types of the students. So again, this is more like a formative setting rather than a summative assessment setting. We are not hoping to make any important decisions, but it is mostly for assessing students for their learning, basically. So when measuring student progress, assessment tools should be really sensitive because, again, even like a little change in learning is important in this case. So that's why the traditional paper-pencil tests are not really suitable, because giving the same tests to all students may not be really suitable because, again, the tests are not really sensitive. Some items could be so easy for some students, or those who struggle with the content may not even answer most of the items on the test. So basically, we need a more sensitive assessment tool to capture the amount of learning or growth in learning or progress. So that's why computerized adaptive testing is a really nice tool for capturing student progress precisely with minimum and consistent error, basically. So that's the main function or main benefit of CAT in this case. So in my study, I'm using a data set from an assessment called STAR rating. So it is coming from a company called Renaissance Learning, or shortly Renaissance. So it's a company in Madison, Wisconsin in the United States. So the STAR rating is an operational CAT, and it's measuring student progress basically in multiple areas: reading, math, and early education, but in this case I'm only focusing on reading. So this exam is given to students in schools from 1st grade until 12th grade. So just to measure student progress during the year, the exam is given multiple times. So the exam basically measures reading comprehension, reading achievement relative to peers between students, and also it looks at individual growth in reading over time. So basically, students just come to school. It's a CAT system. They are just writing the exam or taking the exam multiple times a year. So it's not like a one-time test. So these students are given this test maybe bi-weekly or monthly. So some students can just take the test only 3 times a year. Other students can just take the test 12 times a year if they are eligible or available to take it. So once all the CAT administrations are complete, so we usually observe a plot like this. So on the x-axis, you just see the CAT administrations. In this case, I assume that there are 11 CAT administrations per year. And on the y-axis, you are seeing the scale scores. Those are basically the IRT theta scores, but we just transform, or just this Renaissance transforms those IRT scores to scale scores to make them easier to interpret by parents and kids and other stakeholders. So in this plot, basically the orange line shows a goal line, so which is the expected growth for each student. So in our example, a blue line represents a student who is above this goal line, so meaning that the student really made some progress during the year. After these 11 CAT administrations, so this particular student made really progress. So the progress is somewhat linear, and it is positive. So he or she is above the goal line, so we can just say that the student made enough progress in this area. So this is an opposite example. The goal line is still the same. So we are expecting the students just increase from 520 points to nearly to 590, but the students started around 520-ish and just increased so little, even after 11 administration. So the student did not even make enough progress after 11 CAT administration. So we can just say that this student is probably struggling with the content. So we can even diagnose a student with some learning difficulties and other things depending on extra other tools. But basically the student, no matter what's going on in the school, in the instructional level, is not working. So this student is basically failing or is not making enough progress based on these examinations. So in progress monitoring applications, people typically use ordinary least squares regression to estimate the growth over time. So as you know, OLS is a typical linear regression, so it assumes that the trend will be linear. However, in progress monitoring, the trend is not really linear at all. So because most of the time students just go up and down during the year, they cannot always just make some progress. Sometimes they just feel sick, tired, they didn't study well that day, or they are having certain problems, so they're just getting lower scores, higher scores, lower, higher, but maybe there is a clear trend still, but the scores are not necessarily super linear all the time. And even in our case, one thing that we observed, which was really interesting, that most of the students after the Christmas break, they just do really bad after the very next test, after the Christmas break. So they do very, very nice growth or just progress over time, and after Christmas break, most of them just like do really, really bad. So I don't know what's going on, maybe they eat too much or something. So something's going on, but most of the time they just do really bad right after the Christmas time. So even that one is a big outlier in this graph. So because of this reason, we are not really using the OLS slope estimation. We are using something alternative, which is called the tail sense slope estimation. So in this case, it's pretty similar to OLS, but it is more robust against outliers. So in this case, the number of slopes that we can get in a normal case will be number of tests that we administer times number of tests minus 1 divided by 2. So this is the number of slopes that we can get from each student. And each of the slopes will be computed based on score 2, the second exam, minus score 1 from the first exam. And also we look at the difference between those two exams in terms of dates. Let's say 560 points in the second exam, 530 in the first exam, 30 points difference, which is the numerator. And denominator will be something between the dates. Let's say only 10 days or 15 days between two exams is going to be, then we will just divide those two numbers to get the slope. And at the end, the tail sense slope estimation says, just take a look at all of those possible slopes and then take the median slope out of those possible slopes. So that's going to be the final slope estimation for each student, basically. In this study, we are just trying to look at two specific questions. First, what is the length of time interval needed to use a CAT for progress monitoring? Should we give CAT every week, every other week, once a month, maybe only once a year, maybe probably more than that, but a couple of times a year, or maybe like monthly? So we don't know that question yet, so the answer for this question. And also, how many test administrations are needed to use a CAT for progress monitoring? So should we give the test many times or just a couple of times? Do we really need all those test administrations? Because the students really get tired of this process, so they don't want to take exams every week, obviously, and also the parents don't like this either. And in this case, we are really using a large sample of students, and we only got the data from 2014 and 15 academic year, so we have nearly 6.4 million students. They all received star rating and they completed the tests. So these are all the valid students in the data set. So even though the star rating is given in other countries, including Canada and other European countries, we only limited the sample to the students in the US. And in this study, we are only looking at the first and 8th graders because anything above 8th grade, so the students are really making enough reading levels in the high school level, so there are not many students struggling in reading, so that's why we did not really focus on grades 11 or just 9 to 11 or just 12 in this case, that much. Again, the grade level is first to 8th grade, and we are looking at the star reading skill scores ranging from 600 to 1400 points. And we are looking at the conditional standard error of measurement from each CAT, and we also look at the date that each CAT was administered to look at the slopes. So since we have a really large sample size, almost 6 million students, we looked at the normative slopes for each grade level. So we had nearly 500,000 to 600,000 students for each grade level. So we were able to use those students to create a normative value for each grade level. So because the number is pretty representative, and we looked at multiple years too, the slopes did not really change much, even though we just used a single year to create this normative slope. The numbers are pretty stable across years. The length of time will be the number of days for a student to demonstrate growth. So in this case, we are looking at the median CSCM value from each CAT and divided by the normative slope value. So we assume that whenever the normative slope value will pass the median CSCM, so that's the time, that number of days that we just need to use between each of those examinations. And number of weeks for a student to demonstrate growth is going to be divided by 7, the same thing. This time we are looking at number of days rather than number of, number of weeks rather than number of days. So it is pretty much like the same index, but one is in terms of days, the other one is in terms of weeks. And the number of test administrations is going to be, so if the median CSCM value changed depending on the number of test administrations. Basically, even before we looked at this question, we knew that for CAT, in a typical CAT, in an operational working CAT, so the CSCM value should not really change from one exam to another, because that's the feature of CAT. So, but we still wanted to investigate this empirically, so since we have the data set. So I will just highlight few results in here. So when we looked at the slopes, we just realized that from grade 1 or first grade to 4th grade, the slope values are quite high. But after 5th grade, especially 5th and 6th grade, the slopes are really, really low, meaning that the test is not really sensitive enough to capture learning anymore. And this is kind of like an expected result, because once the students just really reach 6th or 7th grade, they really read very well, actually. So the test is not really sensitive enough to capture their learning anymore. But the students in grade, first grade through 4th grade or 5th grade, they are really making enough progress to show during the academic year. The second thing is, and also the number of days that we need to show enough progress. And as you can see, so like nearly 40, 41 days needed between those tests for first grades, versus for 8th grades we need 267 days, nearly maybe like 8 months or 9 months to show enough progress, depending on the CSCM values. So like I said, it's not really realistic, because that means you will only have one CAT administration per year for 8th graders, versus first graders, probably we can have multiple examinations during a year to capture their growth. So the longer process monitoring durations are necessary as the grade level increases. So that's our main outcome or point in this case. The median CSCM value is around 16 scale points, which is pretty much like the same across all grade levels, which is really nice, again, because that means CAT really works. The CSCM value is more or less stable between the test administrations and also across multiple grade levels. Also, grades 1 through 4, they met the typical progress monitoring period of 20 weeks. So typically, progress monitoring applications are completed within 20 weeks. So, but after 4th grade, so it doesn't seem really realistic. And again, progress monitoring in reading may not be a successful application for higher grade levels, again, because the test may not be even sensitive enough to capture enough learning. Also, they are not really showing enough progress based on this test. So, how many tests should we just give? So, some students only took the test 3 times, some students just completed 11, 12 tests a year. The results just show that pretty much the results are identical, actually. So, it doesn't really matter if you administer the test 3 times or 12 times a year. If you give enough time between the test administrations, you should be able to capture progress pretty precisely. So, you don't really need bi-weekly or like weekly tests, because the CAT is really sensitive enough to capture the progress without loss of error. So even 3 or 4 examinations per year or maybe per semester should be good enough to capture student growth precisely. And again, since it's a CAT, this is not a surprising result. So the median CSEM values, like I said, is very similar for each CAT. And that's why the number of test administrations is not really influential. So the previous studies recommended that we should just use weekly tests. So we do not support this suggestion. And some other studies just show that fewer tests over a longer period, so which is also similar to what we found in this study. So maybe fewer tests with longer intervals between the test administrations should be good enough. So you don't need to bother the students every time, every week to give multiple examinations. Maybe fewer tests, but maybe longer time between those test administrations would be ideal in this case. So in our study, we just recommend that for 15 to 20 weeks, a total of 7 to 10 CATs should be good enough. Even that number is quite high. Or for every 4 weeks over a 20-week period, so up to 5 CAT administrations should be good enough to capture student growth in reading. And again, this is a content-specific result. So in mathematics or other subject areas, the results might be quite different. But again, the progress monitoring applications are usually done in reading. So I don't know why, but the school psychologists are really enjoying the reading in terms of progress monitoring since there are so many students struggling in reading. So as a summary, star rating is a suitable tool for progress monitoring, especially for early grades. So again, for higher grade levels, the test is good but not really sensitive enough. During a school year or intervention time, at least 5 to 6 CATs should be administered, probably in equal intervals. And to ensure meaningful growth, grade levels should be taken into account, again, just like I said. So the earlier grades are better, the later grades, they are not doing well in this particular test. The features of CAT, like sensitivity, low error, low CSCM, the adaptive item selection makes it really a powerful assessment tool for progress monitoring, because again, we really want to detect even like a little increase or decrease in learning. So a typical paper pencil test is not good enough for this purpose. In this case, star rating is a good operational exam for showing us that the CAT can be used for formative assessments and measuring student progress over time. So these are my references, and if there's any questions, so I can just take the questions. Thank you so much. Any questions? Yes.
What is reading?
That's a really good. That's a really good question. It is mostly, I would say, it is 80–90% reading comprehension. It's not really vocabulary. It's not really just completing sentences or something. It's mostly comprehension. Mm-hmm. Yes. How many items? It's a variable length CAT, so there's not a fixed number of items, but I think there's an upper limit. I don't remember it right now, but the number of items really depends on the student. So the test can be longer, shorter, depending on the person.
But in the back.
And also how many passages, because they read the passage,
Mm-hmm.
and then question. And then if there are not many items, there is a very small number of passages. So maybe this is why you don't see any, you cannot monitor the number of passages.
Actually, it's not necessarily related to number of passages, because I think they've been just trying different possibilities, like more passages with more, fewer questions, or fewer passages with more questions, or something like that, and the results are still the same. So for earlier grades, it doesn't really matter, so you can still capture it. For later grades, like I said, the students can already read. So no matter what you give them, longer passages, complicated passages, shorter passages, more items, less items, it doesn't really matter that much because they read well enough. Maybe the test should have been more sensitive. Maybe that's something. Or maybe the content should be adjusted to capture that one. Maybe adding more complex vocabulary or something like that. Yeah. Yeah. Yes. So they don't see the same passage again. Is that what you mean?
Right.
I'm not really sure. I'm not really sure if they are blocking a certain passage, like students don't see it next time. Since there are multiple administrations, probably, I think they are just creating multiple intervals. I'm not sure how they just really specify that portion of the item bank, but every time they just give the same test, but I'm not sure how they adjust it. There's a certain algorithm that they use, but I'm not really sure of that one since they don't release that information to us. Yes?
Could you please show again the results slide?
Mm-hmm. This one?
Yes. I mean, if the results are basically the same with 3 data points and 12 data points,
Mm-hmm.
is the implication of that that the assessment is useless in terms of learning? Because we would expect that more assessment
Mhm.
leads to better learning.
In this case,
If the assessment, if we are measuring through compensatory
Mhm.
education,
the results are the same just because the CSEM is the same across 3 tests versus 12 tests. Even after each CAT administration, the CSEM was, the conditional standard error of measurement was around 16 scale score points. So, it doesn't really matter if it is like 3 CATs, 5, 10, because every time you just take the mean CSEM out of those 12 assessments or within a year or something, so it becomes the same number around 16. So and that's why the results did not really change much, because we looked at CSEM specifically to decide if there's enough progress or not. So I think that's the main reason rather than the test is not working. But yeah, that's a good point actually. Yes?
I'm really curious. I know maybe you don't know the details of their system, but
Mhm.
is it one item pool that is being used for all 8 grades? In other words, is it, that anybody who sits down, no matter what grade level they are, they get into this test and they're getting items selected out of one item pool? Or is it, separate item pools that are somehow linked to get them on the same?
I think that's the case. So I think there are separate item pools with some linking items between those things. So they every time link the scores between multiple grades, so they are not really receiving the same item bank, as far as I know.
Okay, so if you're, let's say, a poor-performing 5th grade student, then you won't get some of the items that might be given to 2nd grade students.
Probably.
Probably not, you have some other kind of thing in there. Because I'm trying to think about this, as you go up in grades, when you get to 7 and 8, the purposes of reading change. And people are now using reading for information and reading for literary, uses, and they're not teaching reading as such.
That's right.
As they do in the early grades.
That's
where
true.
They're actually actively teaching reading.
Mhm.
So it's not really surprising in a sense unless you change. You've already mentioned this. You have to change the emphasis of the exam when you get up to the 7th and 8th grade. And of course, knowing my perspective on this, there's a change in dimensionality.
Maybe I should suggest that. So, yeah, but yes, that's a really good point. In the earlier grades, since the students are really, at the beginning, they don't read at all. So then they start reading gradually, and then they are getting better and better and better. And at some point, like you said, maybe the reading passages are not even good enough for them to capture their learning. Maybe you need to give them more complex vocabulary tests or more complicated reading tasks so they can just show if they are really proficient in reading at their grade level rather than a typical test across multiple grade levels. Yeah, that's a good point. Any further questions? Nothing? All right. Thank you then. So, thank you.